Okay, I'm going to go over this test, and I'm also going to try to explain the uh, chain rule a little bit different. Okay, so we have here y equals ln of some stuff. I'm going to call it stuff. It's 5x to the third times the... Now, if we're trying to find the derivative of this, or dy dx, well, the derivative of ln of x, according to your notes, is 1 over x. But I don't think I made it clear that, okay, if it's not of x, if we're doing the derivative of ln of something more complicated, some ln of some stuff dx, it becomes 1 over the stuff. And then, since that's not just an x, we then have to do the derivative of the stuff. So, this is the stuff that's inside the ln. The derivative of ln is 1 over whatever the stuff is, 1 over it. So, the derivative of this is 1 over the stuff. Times the derivative of the stuff. Now, some of you just did the derivative of the stuff and left the ln. Some of you did the derivative of the stuff and put it underneath times x. But it's the ln, it takes whatever this is and puts it under 1. That's the derivative of ln of something, 1 over the something. Times the derivative of the something. And there's two things added, and this is times both of them, so we have to put parentheses, and the derivative of this part of the stuff is 15x squared, 3 times 5, 15x to 1 less power, and the derivative of arctangent of x. Now, that's a simple x, so we can just use the rule for arctangent of x. And you should have that on your note card. The derivative of arctangent of x, and that should have been RC, is 1 plus whatever this stuff is squared, and since it's just an x, we would go times the derivative of the stuff, but that would be dx dx, or 1. So this is the answer to the first one. Okay, number 2. So we have some stuff to the third power. The power rule says you take 3 down this to 1 less power. So if it was x to the third, it would be the derivative of that is 3x squared. But if this is messier than just x to the third, then we have to do the derivative of the stuff. So the derivative of cosine of 5x to the third is, if that's the stuff, it becomes 3 times the stuff to 1 less power times the derivative of the stuff. And the stuff is cosine of 5x. But the derivative of the cosine of 5x, it's the cosine, but of some other stuff. So we have 3 cosine 5x all of this to the second. The derivative of cosine of just x is negative sine x. But if it's of some stuff, then it's the sine of that stuff times the derivative of the stuff. Chain rule. So the derivative of this is negative sine 5x. That's the derivative of cosine of something. It's the sine of the something. And then it's times the derivative of the inside or the stuff. And the derivative of 5x, the stuff that's in the cosine, is just 5. And so the answer to this problem is 3 cosine 5x squared, I could put the square there or around it, times a negative sine of 5x times the derivative of 5x, 5. Now I could write this as negative 15 cosine to the third of 5 of the sec to the second. I don't know where I got the third. To the second of 5x times, I brought the minus out and the 5 out, so I can't pull that 5 out. And now we have to get the slope of the tangent line at pi over 6. So we put pi over 6 in for the x's. So we're finding the cosine at 5 pi over 6 and the sine at 5 pi over 6. Pi over 6, 2, 6, 3, 6, 4, 6, 5, 6, over here at 150 degrees in the unit circle. And this is the short leg on a 30 degree or pi over 6 angle, which is 1/2, and it's positive, and the long leg is the square root of 3 over 2, and it's negative at 5 pi over 6, and the hypotenuse is 1. So we have negative 15 times cosine of 5 pi over 6, which is adjacent over hypotenuse, so it's this, squared. So negative square root of 3 squared is 3. 2 squared is 4. And then sine of this same 5 pi over 6 is 1/2. So we have 45 over 8. Okay. Page 2. So we have 5y squared minus 2x equals 2 to the y. And if you want to find the slope of this, you could solve for y and then find dy dx, although it's pretty darn hard to solve for y when it's a y squared and 2 to the power y. So you probably want to do implicit differentiation. So this is a constant, so you don't have to use the product rule. It's 5 times the derivative of y squared. But we need this slope is dy dx. So we don't want to do dy's, but we're going to have to here. So we get the derivative of y to the 2 is 2y to the 1, where this is something that could depend on x. And so we need to find out, we have to do the chain rule, we have to take the derivative of the inside, the stuff, and that's going to be dy dx. Since we haven't solved for it, we don't know how to find that exactly. Now to take the derivative of negative 2x, that's negative 2 times the derivative of the inside, the stuff. Derivative of x is dx dx, or 1, so we don't have to do anything. Since the variable was x, we're good. When it's not x, then we have to add on, well, however, y changes when x changes. And here we have 2 to the y, and 2 to a power's derivative is 2 to the power times ln of the base. But the power was y, not x. And so we then have to say, okay, that's some sort of stuff. Y is maybe x squared or some way, we don't know. So we have to say times the derivative of the power with respect to x. So when you're doing implicit differentiation, if the variable is not x, the one that you're trying to find, the independent variable, then you have to, on any term that has a variable that depends on x, you need to make it have the dy dx. This portion needs a dy dx because the variable wasn't x. So, to solve for dy dx, where we have 10y to the first power, not derivative there, but first power, minus 2 equals ln 2 times 2 to the y dy dx. There's a dy dx in this term and in this term, but not in this one. So I'm going to subtract this amount from this side. So I'm going to get minus 2 equals ln 2 times 2 to the y. That's times dy dx. And so is this 10y dy dx that I'm subtracting off of both sides. So both this and this have a dy dx, so I can factor out the dy dx. And then I can solve for the slope by dividing this expression into this. And that's what the slope will be if I know the x and y coordinates. Dy dx. And it's telling me the y coordinate is 1. And I see that there's only y's here. Now, if I wanted the x, if I had an x in here, I'd put 1 into this equation and figure out the x that goes with it. Let's just do that so you see how that works. Don't need to on this problem, but it says the y coordinate is 1, and I'm going to find the x coordinate. So 5 times 1 squared is 5, minus 2 times x, which we don't know, equals 2 to the y, but we're making y 1, so we got 2 to the 1, which is 2. If we subtract 5, we get minus 2x equals negative 3. Divide by both sides by negative 2. And we get x is 1.5. So if there was x's in here, I'd put 1.5 in for them. And for the y's, I'm going to put 1. So the slope of the tangent line is -2 over ln2 times 2 to the 1 minus 10 times 1, which is minus 10, equals the slope of this graph at y equal 1. And you can work that out in a decimal if you need. Okay, number 4. So we want dy dx. We want the derivative. This is a quotient. And a quotient rule is derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. Well, we can do that pretty quickly. Now, the derivative of the numerator, that numerator is 2x plus 3 to the 1/5. So its derivative, we can do the power rule to start with. 1/5 this to 1 less. 1/5 2x plus 3 to 1 less than 1/5 is minus 4/5 times the derivative of the inside, and the derivative of the inside is times 2. So the derivative of the numerator is 1/5 2x plus 3 to the negative 4/5 and the numerator, the derivative of the denominator is, the denominator. Derivative of the numerator times the denominator. Minus the derivative of the denominator. So the derivative of arc cosine looks a lot like the derivative of arc sine. It's 1 over the square root of 1 minus x squared if it's just an x. But if it's x squared in there, it's whatever that is squared. And if this is not just an x, then the chain rule says we got to take times the derivative of the x squared, which is 2x. So I can just put it there. Or I could put it over here, times 2x, and leave this a 1. And put a 2x here, same thing, because I can multiply this. 1 times this is that, and this would go there. So that's the derivative of the denominator times the numerator. And I can write it with a radical sign, or I can write it to the 1/5 power, but it's 2x plus 3. And all of that is divided by the denominator squared. Okay. Number 5. So we have a product. So we take the derivative of the first times the second plus the derivative of the second, and since it is just an x, it's just 1 over x times the first. That's the chain rule, or the product rule on these two. Then I have to do the derivative of sine x, which is cosine x. And I'm supposed to find it at 2, and I can do ln of 2 because it's a positive number. So it does exist. And so we get, we're putting in 2, so we get 4 ln 2 plus 1/2 times 2 squared, which one of these x's will cancel, and so it's just 1 over x over 1, which is x. It's just x, which is 2. And then we have plus the cosine, and the x is 2. And you can type that into calculator and get the slope of the tangent line. Now, if we go to minus 5 for x, the natural log doesn't exist there. So this equation is no longer valid. So ln of negative 5 is not defined. That's why it does not exist. Okay, an easy one. The derivative of the position vector equation is the velocity. H prime of t is the velocity. So 2 down times negative 4.9 is negative 9.8 t to 1 less power. 30t's derivative is just 30. And the derivative of constant is gone, and so there's the equation of the velocity. And the second derivative of the position vector equation is the first derivative of the velocity equation, which is the acceleration equation. And so we got to take the derivative of this derivative, and that's negative 9.8. And you could put meters per second squared on there if you want. Determine the velocity at 2 seconds. So we go to here, put 2 in here, and we get 9.8, negative 9.8 times 2 plus 70. Whatever that is, that's the answer. And you could leave it like that if you want. Oh, except we need units because the velocity is in, let's see, where the distance is measured in meters per second. And finally, the last problem. So it says f of stuff. The derivative of f of some stuff would be f prime of the stuff. You don't change the stuff in when you're taking the derivative of the bigger picture. Times, on the outside, the derivative of the stuff. Now, the derivative of 0.2 is 0, because there's no x on it, plus the derivative of g of something is g prime of that something, of that stuff, And then to find the derivative of this completely, we have to do the derivative of 2x. So it's times 2d d2x dx, which is just a 2. So we need the slope of f at this place. Well, what is that place? Well, 2x is 1.4. So we're finding the slope of f at 0.2 plus at 1.4, because we're doing 2 times 0.7, 1.4. G of 1.4 is 0.7. And then we're taking that times, well, this times 0 is nothing, and this times this. This is the slope of g at 2 times x, which is 1.4. And then we're taking all this answer times 2. Now, to get the slope of f at, let's see, this adds to be 0.9. So I need the slope of f at 0.9. So I need the slope here. And the central difference theorem says if you use the subtract the 2 on the either side of that. So that's going to be, if we do the larger minus the small, the y2 minus y1, on either side of 0.9, it's going to be 0.91 minus 1.11 over the change in the x on either side of 0.9, which is 1 minus 0.8, which is 0.2. But I'll write 1 minus 0.8. And so from here to there is 20, or 0.2, I should say. And 1 minus 0.8 is 0.2. Oh, this minus this is negative 0.2. So this, the slope of f near the 0.9 looks to be about minus 1. So this is negative 1. Now we need g at 1.4. The slope of g at 1.4, 1.4 g. So we do 0.67 minus 0.74. No, let's see. I want to do 1.4 g. 0.7 minus 1.4. So I want to go 1 past 0.67 minus 1 before 0.74. Did that before. Over 1.5 minus 1.3, or 0.2. So what does this equal? Well, this is going up by 0.07. So I think that's, if I subtract it the other way, I'll get the negative of the answer. And from 67 to 74 is 7. So in that place, yes. And I got to divide by 0.2, which is dividing, if I multiply numerator and denominator by 10, I get 0.7 divided by 2, which is 0.35, negative 0.35. So we got minus 1 times negative 0.35 times 2. Let's see, that would be times 2. So 2 times negative 0.35 is negative 0.7 times the negative 1 is 0.7.